Hey, here we are. Here we are. It is 2:10 UTC, and it is the beginning of another live stream of Astronomy Daily Live. So, hey, everybody. Hope everybody's doing well. Those of you who are joining live and those who are joining in later, nice to see everybody. Just coming in from a calibration run with the scope and the system, grabbing my flats and my darks and my biases so I can apply that calibration data hopefully to the actual data that I'll be collecting later tonight. Um, it's yep, cleared up. It's there were a few little clouds around sunset, and as soon as the sun went down, whoop, they're just gone. Now I'm just dealing with some wind. The wind is supposed to die down as well, so hopefully, because it's going to be a cold, relatively speaking, a cold night. Um, it's going to be getting into the 30s here, with some wind, Fahrenheit, that is. So yeah, it's going to be cold. I'm going to have to bundle up and just uh, just do it. That is the astronomer's life, at least this astronomer's life. Most astronomers, when they and actually I haven't talked about this in a little while. Maybe I'll start there. Most astronomers uh, spend very little time at on the telescope at all. And these days, if at all, because uh, there are many instances where you can do um, remote observing or robotic um, um, observing. And so the astronomers don't really even have to travel anymore um, to get their data. But if they do travel, um, they have to first write a proposal that sort of explains um, the observations that they want to make, and it has to be detailed enough, and it has to explain, it has to say why and when and who and where, all of that. That gets submitted to a committee. I'm just setting up my Linux machine here and my smartphone so I can watch the live stream. Hey everybody! Hey hey hey! I'm here, pretty much on time. Just taking calibration data. That went very well. The sky is clear. It's the seeing isn't all that great. Um, uh, Before I forget, make sure in the next few days to go out. Um, maybe a half an hour after sunset or so. Maybe a little later than that. Yeah, half an hour or so. Look due east. You'll see Venus, bright Venus, and to its upper right, um, by a few degrees, you'll see the planet Mercury, and it's not entirely rare to see Mercury, but it's you don't get to see it all that often, so it's kind of a nice treat to see Mercury out there. So take a look at that. It's yeah, it you know as I said, you don't get that much of a chance to see it. This is about as far away from the sun that it actually gets. So now is a good time to do that. Let me adjust my my lighting a little bit. Yeah, all right, something like that. Here, I'll scooch in. I'll scooch in a little bit. So yeah, Mercury is up, visible, looking awesome as always. A nice treat. So cheers to Mercury. Cheers. So yeah, take a look over the next few days. It'll be visible just just you know just in the vicinity of Venus. The big bright one, almost due east or so. There'll be a fainter one next to it, sort of orangish or reddish. That's Mercury. That's Mercury, especially if you're seeing it in the twilight sky. Still, it's got to be pretty bright. So yeah, take a look at that. Anyway, so modern astronomers, yeah, don't spend a lot of time looking through um, telescopes. They uh, uh, they write a proposal that they then submit to a committee, which is called the Telescope Acquisition or Allocation Committee, and that committee sort of evaluates the um, proposed observations, and it gets discussed and it gets this is and that and all of that. Finally, they're granted permission to use telescope time, precious telescope time, in order to make their observations. They have to specify what kind of instrumentation uh, they want to use. All kinds of parameters, right? All kinds, and they finally do that. And if they travel to the actual site, um, they they don't really have to you know sit in a cold dome in front of an eyepiece, right? They sit in a nice warm control room. Hold on one second, I got a kitty alert. All right, kitty alert avoided. Always kitty alerts. So yeah, they sit in a nice warm control room and basically just sort of watch the data being collected by like the telescope operator. But that's not always the case. Sometimes the astronomers do have to control the telescope and control all the instrumentation and all the computers and all of that. And it gets, um, pretty intense. But yeah, there's a lot of um, um, bureaucracy. On top of all of that, if the institution that you work for doesn't own the telescope, then you have to pay for it, and it's extremely expensive. It's several $1,000s per night, whether it's clear or not. So that's another thing. You take your chances when it comes to um, the weather. So yeah, you may have worked on this proposal for weeks or months. You've written it all. You submit it. It takes a couple of weeks, a couple of months to for the committee to decide that what you're proposing is good enough, Um, it's extremely competitive. Um, Ground-based is, especially, of course, the bigger scopes. Think about Hubble. Okay, that's one telescope that all the astronomers on the entire planet want, and yeah, it's just crazy. So that's why I say, yeah, JWST, yeah, let's do that, but let's launch 10 or 20 Hubbles as well, just just to give the astronomers a little bit more space telescope time. I think that would be awesome. But yeah, so it takes a long time. Bureaucracy is insane. Um, uh, you have to travel. You have to go up there. Sometimes you have to run it, then you have to pay for it. You've got to pay for all your travel expenses and for time um, at the scope. And you might have 1 or 2 or 3 nights if you're lucky. And if it's cloudy, you're screwed. You're screwed. So yeah, it's a hard life. It's a hard life. So, but so yeah, that's what you have to do, and it doesn't really matter what size of scope or what facilities you have. The process is pretty much the same. I'm lucky because I can just walk outside, set things up, and it's done. And hopefully, I can get some science done as well. Tonight's run will hopefully show that photometrically I can do really well in terms of the accuracy of my measurements, and also precision, consistency. So I can measure things well and precisely. And I'll probably stick with um, the field around um, M41. Uh, it's a nice, rich field of stars. Gaia has all the stars in it. Um, so I know the positions, I know the magnitudes. That's all I need in order to measure or compare my measurements with that, and we'll see how accurate and precise it can be. So as I said right at the beginning, about a half an hour after sunset, go look east. You will see Venus, big bright Venus, and to its upper right, maybe, I don't know, 2 or 3 degrees or so, is the planet Mercury. So take a look at that. Don't forget to. I think this is the best you're going to be able to see it, at least this year, in the evening, right? I think Mercury's year is something like 88 days. So um, uh, yeah, it's not going to be an evening star again for another 88 days, and that puts us into June. And depending on configurations and all that, how far away the planet actually um, looks like it is from the sun. I I've been told, I've heard at least, that this is the furthest away from the sun that it's going to be this year. So I haven't confirmed that, but yeah, that's probably about right. Cheers. So I thought since I was talking about Mercury, we could actually go and see. I haven't investigated this, so this might be a fruitless journey, but there is or was I th- I want to say was. I don't remember if the Messenger spacecraft is still operational or not. I want to say that it isn't, but oh, I can't be exactly sure. Can't be exactly sure. But what I thought that I would do is just try to see if we can find any pictures of Mercury tonight. So I'm going to share my screen and we can go on this journey together. So what I'm going to do first, wow, I don't know why that did that. That's stupid. So, of course, Google is our friend. So I'm going to say Mercury Messenger and see what comes up here. Maybe I'll have to do Messenger spacecraft. No, Messenger. Okay, so it orbited the planet between 2011 and 2015. Now, what happened to it? I mean, it's speaking as though it isn't. I mean, when it says it orbited the planet between such and such a date, that sort of implies that it isn't anymore. Did it smash into the planet? I don't remember. Let's see. Mission profile, orbital insertion, primary science, extended mission, end of mission. Let's just see. Let's go to the end and see what happens. Okay, so after running out of propellant, uh, Messenger entered its expected terminal phase, orbital decay, uh, studying Mercury during its decay period. The spacecraft crashed into the surface of Mercury on April 30th, 2015 at 1926 GMT at a velocity of 14,000 kilometers per hour, probably creating a crater. So okay, so it just smashed into the planet at at the end. So all right. Well, let's see. I wonder if there's like an image archive anywhere. Let's see. Let's see. Lots of references, of course. Messenger mission homepage, flyby visualization tool, Mercury data. Okay, so I guess let's go to, so this is the official information regarding the mission. So let's go to there. Yeah, impact science. I love impact science. So here's images. Let's see. We'll just look around on Mercury. I always thought, that it sort of looked a lot like the moon. I mean, this looks a lot like what the moon looks like, but of course it isn't the moon. The rim of Rembrandt. Okay. Oh, there it is. Mercury. Wide angle camera towards Mercury's southern horizon. The rim of Rembrandt basin. So that's, I guess that's this rim here. So this must be Rembrandt Basin. I know nothing about Mercury. Nothing. Except that it's really, really strange, right? It's not exactly tidally locked to the sun, but I think, and maybe we can get some info on that. Uh, let's go back to the Wikipedia pages, way back here, and see. Come on, let's see. Oh, this is about Messenger. So, okay, yeah. Let's uh, let's go to Mercury itself and see if we can find anything interesting about it. Come on. Gosh. So orbital period is 88 days. Saying, is it going to tell us anything else interesting about that? Got a synodic period of 115 days. It's just a very strange thing. I was told, and I should look into this a little bit more before I dump it on you guys. But yeah, I was told, that the sort of the path of the sun in Mercury's sky makes an interesting uh, pattern. Uh, don't know much about that at all. I'll have to investigate it a little bit more. This was just a spur of the moment thought. It, it'd be interesting to at least take a look at some pictures. So let's do that. Let's see, where is, okay, there it is. So I hope everybody's doing well today. Hope your past 23 hours was good. Everything's good over here. Let's just do what we do with Mars, except let's do it with Mercury and just sort of take a look at these awesome landscapes. Wow. Look at these funny cracks. Huh. A lot of these craters have these bumps in the middle. You see? A lot of them do. These over here. Yeah, interesting. Don't know if we'll ever actually get to be on a place like that. It's that's a pretty rough place. That's a pretty rough place. Either very hot or very cold. No atmosphere as far as I know. Huh. Huh. Yeah. Go figure that one. See, whenever I see these, the first thing I see is all the stuff is popping out. And I know that that isn't the case. I know that it's the other way around, but I actually have to try really hard to see it um, the other way around. I have to trick my eyes into seeing it the other way around. And it sometimes I can do it, and sometimes I can't. And right now, I cannot do it. These things are just popping out, uh, and there's no way I can reverse that. Drives me insane. Yeah, Tom, it's something weird like that. Yeah, something really weird like that. I think you're exactly right, um, um, Uncle Bill. I think Mercury Mappers is one of the CosmoQuest projects. So yeah, I think you're exactly right. I don't know what they're pointing to here. It looks like just some ridges of some sort. But what an amazing place, you know? What an absolutely amazing place. Resolution here is absolutely terrible too, right? I mean, these are huge craters, and we're not seeing a lot of detail. We're just not. We're just not. Yeah, citizen science. I should someday. I'm going to have to go off on my rant about citizen science again. Um, I yeah, I I mainly just have a problem with terminology, um, because, and I'm not going to get into it now, um, but um, I don't really think that anybody who is participating uh, in like the mappers thing is actually doing science. They're collecting data for scientists, but to call that doing science, mm, no, I've got, and as I said, it's just a problem with terminology. It's not, I mean, I think what they're doing is really awesome and really cool. But um, uh, citizen scientists, for the most part, are data collectors because software can't do it well, and there's so much of it that grad students, um, uh, you know, there aren't enough of them. So you have to find volunteers. And I said I wasn't going to go on a rant, but it's sort of Tom Sawyering, sort of. It's like I've got to paint this fence, and that's a lot of work. That's a lot of work. Let me see if I can make this such that it doesn't look quite so bad. In fact, let me make it sound like it's something, that is really awesome. So I don't think that is the intention, but that's sort of, that's at least my interpretation of that. However, the data that's being collected, um, just like that awesomely painted white fence at the end, is awesome, is absolutely awesome. So, the data that's being collected is absolutely great, and um, people who want to do that is awesome. It's absolutely great. I like it. I like it. Citizen science, the collection and analysis of data relating to the natural world by members of the general public. Yeah, I, you know, probably I'm speaking a little bit out of ignorance too, because I don't see a lot of of the analysis part. Um, I see, people identifying craters, um, and doing identification uh, of things, which is collecting data, but I don't see a lot of of the analysis of data. And again, science is a process. It's a big long thing. Um, just just not a couple of parts. So it's just a terminology thing, and uh, sometimes I'm way too hung up on that. And so yeah, I just need to chill and realize that this is extremely awesome and yeah. But anyway, Mercury is one of the projects that is citizen science stuff going on there. Yeah, for sure. And if you want to do it, do it. I think that's great. So there's another nice shot of looks like a mountain range, maybe the edge of a very old crater, maybe inside of another one. Kind of hard to tell. Kind of hard to tell. Let's say, okay, cool, very cool. There's just we're getting into an era where there's just so much data. There's just tons and tons, and it's not going to get any less. It's just going to get more and more and more and more. And so uh, uh, what better way? I mean, it's a win-win, right? Because people um, get involved, make contributions, even if it is just collecting data. I mean, if they're happy doing that, who am I to judge, right? I think it's great. I'm just saying that, yeah. So this is sort of like a topological map. That's pretty awesome. Wow. I don't think no, this can't be the whole planet, right? I mean, it's deceptively round, which but yeah, no. This is just a portion, but look at the topology. It's just wow. You know, I assume that these are high points. The reds are the high points, and blues at the low points. There's no scale on here. We need to put scales on here so we know what we're looking at, people. But it's very cool. And yeah, this is using a laser altimeter, just like the one I was talking about a couple of days ago that they were going to be using on Ganymede. Um, at least the same concept, right? So that's very awesome. It's beautiful too. Beautiful color. Just showing the different heights, and it's a rough place. It's a rough, bumpy place. Very awesome though. So go out and look at Mercury while you can. Now is a good time. Do it. Are these? I don't know what these are. Okay, instruments aboard the NASA's Messenger spacecraft have been collecting surface measurement. Okay, let's see if there's any more info about these. This is looking at minerals, apparently. Okay, yeah, surface composition spectrometers. So yeah, it's looking at the composition of the dirt. And then, you know, they colorize it, of course, to make things stand out a little bit. But yeah, you know, what a what a wonderfully complex place. Just like everywhere else we look. To this like this line of craters. I assume that this is the whole planet here now. You know, that we're seeing, you know, like some quadrants. See if we can line any of these things up. Probably not. Let's see. Yeah, kind of hard to see where they overlap. Maybe we're looking. Yeah, I don't know. I don't know. Fantastic though. What a uh, huge variety of stuff. And you know the resolution here isn't all that great, so you know that it's even more complicated than that. Let's see. What else we got? More images. Taking a look at Mercury from the Messenger spacecraft. Messenger looks like it orbited Mercury from 2011 to 2015, and it just at the end it ran out of gas, and they smashed it into the planet. Huh, that's kind of interesting. It's sort of brighter here in the middle than it is everywhere else. Don't know what that's all about. Large depressions found in the floor have been interpreted as evidence for explosive volcanism. Hmm. Okay, interesting. So they think that this is volcanic, old um, volcanoes. I don't think that they're saying that they're anything active. That's pretty cool, though. Pretty cool. I think we're just gonna hang on Mercury tonight, if that's okay, unless anybody else has anything interesting to bring up. We can just do a Mercury night. Wow, look at this. What a great angle. What a great angle to see that. I guess you'd call that a mountain range of some sort inside of a crater. Yeah, oblique images highlights the spectacular interior of Abaddon crater. Yeah, wow, that's fantastic. What a great angle. Great angle. So, you know, the sun is over here, right? Shooting in this way, casting these really awesome shadows. And so yeah, you really get a sense of depth of depth there. Yeah, yeah. Keep having to do the more images thing. Let's see what else they got. For some reason, they've got a picture of a comet. I don't know what that's all about. We were they making observations of comets from Mercury? Yeah. So they actually got a picture of a comet from Mercury. Wow, that's pretty awesome. That's fantastic. Low resolution, but hey, what a unique vantage point. unusual, I guess is the right term there. An unusual vantage point. Let's see what else we got here. Mercury is an awesome, awesome place. The first, not the first one, but one of the short stories in Asimov's I, Robot books is a story about a either one robot or a few robots that had some trouble at Mercury. Oh, is that fantastic or what? Look at that. Yeah, that's fabulous. Wow. Great place to visit. I don't know if I'd want to live there, but hey, I'll go. Nice. Nice, nice. Let's see what else we got here for Messenger. Anything else interesting? I don't know. Just lost my screen. Got to get it back. There we go. Anything else interesting about Messenger? I don't think that there are any other spacecraft being planned to go to Mercury. I don't think that there are any spacecraft going to Venus either. And that's not very nice. Yeah, I don't really see anything else there at all. Let's see if any of these other things catch my eye. This one's kind of interesting. Tectonically active planet Mercury. Wow. Didn't know that one. Again, this is just showing topology, but yeah, pretty spectacular topology. Reveal previously undetected small fault scarps, cliff-like landforms that resemble stair steps. Scarps small enough that they think that they are geologically young. Mercury might still be contracting. Yeah, very cool. Nice picture. Beautiful, beautiful. Awesome, awesome. Stark. Intense, intensely insane place. Bepi Colombo? I I've never heard of that, Tom. Bepi Colombo? Never heard of that. Let's find out what that's all about. Bepi Colombo? Cool. So they are sending another spacecraft to Mercury. It's ESA and JAXA. Cool. Colombo is Europe's first mission to Mercury. It'll set off in 2018. That's this year. Arrives in 2025. So nominal 1 year. Got a green light for the launch site. Be ready for shipping to the spaceport to begin final preparations for launch. Let's find out when this launch is, when and where. Mission passed, major review. Launch window is open from the 5th of October to the 29th of November. Final weeks will see the spacecraft stack inside the Ariane 5. Transfer module will carry two science orbiters. Wow. We're going to have two spacecraft. Complementary measurements. Wow, that's awesome. That is so cool. Thanks, Tom, for bringing that up. That is very, very exciting. Okay, so here's a little timeline here. Let's see. We'll start at the beginning. Okay, there's launch, October, Earth flyby, Venus flyby, Venus flyby, Mercury flyby, Mercury flyby, Mercury flyby, flyby, flyby. Okay, so yeah. So it looks like they're going to do an Earth flyby, a Venus flyby, and then a bunch of different passes. So it sort of looks like maybe it'll be in a solar orbit, a sun orbit, and just hit Mercury a few times. 2nd of October, 23rd of June, 5th of September. Yeah. It sort of looks like, but wow, very cool. Very cool. Bepi Colombo. That's fantastic. Okay. Solar power, electric propulsion, and 9 gravity assist flybys of Earth. Wow. Okay. See if there's any more info anywhere. I'd like to see a timeline that doesn't fly by so fast. There's a little fact sheet here. Let's see. Okay, so yeah, it's actually going to be orbiting, at least eventually. Okay, so all the flybys are just to get it into orbit. I gotcha. Determine the origin of Mercury's magnetic field. So there's a planetary orbiter and a magnetospheric orbiter. Okay. Polar orbits, 2.3 hours and 9.3 hours. Payload mass, instrumentation, 11 instruments, cameras, spectrometers, yay, radiometers, laser altimeters, magnetometers. Awesome. Accelerometer. Okay, here we go. Okay, so launch in October 2018. So that's just a few months from now. Fly by Earth in 2020. Venus in 2020. Venus again. Mercury. Wow. So it finally arrives, quote unquote, arrives at Mercury on the 5th of December 2025, and they finally get into orbit March 14th, 2026. So it's going to take them like 8 years, 7.5 years to actually get into orbit, and then they're going to have at least planned a 1-year mission, which will hopefully be extended. Uh, yeah, awesome. And yeah, they're gonna science it, man. They are gonna science it to death. That's cool. I wonder what they're gonna do with them after they're done. So wow, look at the data rate. 50 kilobits per second, 5 kilobits per second. So yeah, this isn't New Horizons scale, but it's pretty close. Pretty close. Pretty awesome though. Wow. 7.2 year cruise phase. Ion propulsion. That's awesome. Okay, so these two spacecraft go together and then they split apart once they get there. That's cool. That's very cool. All right. Well, I think that I'm going to get out of here. I've got to start preparations for observing tonight, see what the sky looks like, see what the see what the wind out there is doing. As long as the wind isn't too bad, it doesn't jostle um, the scope around too much. At the moment, I don't have an observatory or anything, so I'm fully exposed to to the wind. So gusts gusts are killers. So, but we'll see how that goes. And yeah, I think yeah, the mothership is calling. So yeah, I better get up and out. And yeah, it might be a long night. So, but hopefully the fruits of this labor are going to be some accurate and precise photometric measurements, and that that is sort of the last thing that I have to do to really convince myself that the system that I have is good enough to do what I actually want to do, which I'm excited to talk about. So yeah, all right, I'm gonna get out of here for now. Thanks for coming in. You guys are awesome. If you're watching this later and have stumbled upon this, make sure to subscribe. Make sure to hit the like or the not like, um, whichever you prefer. Make sure to share this around. I definitely want to grow the crowd. Definitely want to grow the crowd. Um, and I think that will happen with time. Um, just need a little bit of patience and persistence. For me, this is extremely easy and extremely fun. Um, it's no work at all. It's not a pain at all. I'm doing this anyway. I sit back, I think about astronomy, and I thought it's like, why not, share a little bit, bring in some friends, and yeah, just have a good time, casual, fun, um, slightly educational, I hope, and yeah, yeah. All right, I'm gonna get out of here. Yeah, hit the notifications, um, and yeah, I will be back here again tomorrow at 2 hours UTC. If it's clear tomorrow night, if it's clear again tomorrow night, I might be running late again with calibrations and stuff. It just so happens that my local sunset here coincides with, sort of the beginning of this live stream. So you know, I've got to balance things. You guys are patient, so me being a little bit late, I think especially if I just let you know, then it's no big deal. No big deal. So yeah. All right, I'm gonna get out of here. Yeah. Yep. The mothership is calling, so I'm gonna get back up. I'm gonna say cheers. Have a great evening. Have a great day. Um, think astronomy, man. That's it's awesome. All right. I think tomorrow maybe I'll make some comments on um, 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 Elon Musk's um, Q&A at South by Southwest. He said some interesting things, and so maybe I'll have some comments on that. I'm probably going to watch it again. I watched it um, this morning, and I think I want to watch it again, and then maybe have a discussion about that. Because yeah, he's saying some interesting things, and well, we'll see. We'll see. All right, I'm gonna get out of here for now. Take care, and I will see you on the spin. All right. Bye bye.